Hey guys, how's it going? This is Akhil back with another video, and in this video I'm going to share with you the solution for the first question, valid parenthesis 1 in the contest of Scanity April 12, as you have seen here already. Okay, so basically you are given a string of open and close parentheses as just the characters, and you have to reduce the longest valid parenthesis out of that. And valid parenthesis, that means you are having a equal number of open and close parentheses in respective order. And also when they mean the longest here is that it is consecutive. All right, so we'll see the first example here. This first character doesn't have a counterpart that so that implies that does not belong to the valid parenthesis. So these two form the answer, right? So you have two characters forming the valid parenthesis and are consecutive, so we got 2 as the answer. And you also don't have another set of valid parentheses to compare that this is the longest or not. Alright, so we just return the answer as 2, and here you have the longest consecutive valid parenthesis uh, of 4. Alright, this is length 4 and we don't have another set of valid parentheses, so this will be the longest parenthesis. Alright, and we'll try to solve this problem using a pretty naive approach. As you have known, this is a easy problem using a stack. We can simply say whether a set of parentheses is valid or not. When we encounter a open parenthesis, we push that into the stack, and when we encounter this closed parenthesis, we just pop out from the stack if there is something existing already in the stack. Alright, so we'll just do that in a second. And and keep in mind that this is not the final answer. If you are I highly encourage you to check the answer in the code that I have given in the description. Okay, so basically you just take the input and just define a function that does all these things. So this s is an input, and for everything that is in the s, if that is equal to, I mean, if that is a closed parenthesis, and if that is there, then you just append this thing into this x. I mean then, and if x is just a closed parenthesis, we just have to pop. And keep in mind that we cannot pop from the stack that has no elements, right? So we have to check whether there is stack or not. And when we pop, that means only then that means we have a set of valid parentheses. Alright, so we increment that by 2. I mean, we have the answer as 0 in the beginning, initialized to 0, and so when we are popping, that means there is already some open parentheses in the stack, indicating that this totally forms 2 parentheses, I mean a set or a pair of parentheses. Alright, so we just return the answer to be yes. If this will be submitted and this will not give you the sufficient answer, this has to be checked with all the set of valid parentheses as well as consecutive. The word longest means that it has to be adjacent to each other. All the pairs have to be adjacent to each other, and if there is the key point in this is we have to identify the breakpoint that separates two different set of parentheses, two different set of valid parentheses, right? So if we try submitting this, we will get a wrong answer. Wait a second, we just have to make a function call. We just take the function call and print that. There is no response to stack is undefined. Okay, right. if you try to submit this question, I mean if this solution, then you'll get a few test cases gone wrong, and this should not be surprising for you because you are not comparing this with any other set of valid parentheses, right? So a few cases that we might be missing here is, I'll show you in a second, this. So whenever these two are the test cases that we are losing because we did not check for the breakpoints between two valid parentheses. So what we are trying to do here is we are pushing this, and we are, when this is encountered, this will be popped, and when this is encountered, so you don't have anything in the stack, and you also get something invalid. All right, so we just have to make the result as 0. I mean, this has to be 2 and the other part has to be 4, right? So if this has to be 4, we just have to make the result as 0 at this particular point and then increment from here on. So to indicate this, so this is a easy test case where we can have a closed parenthesis coming in and also the stack is empty. So this indicates that we are getting an invalid character, so we just have to stop incrementing the consecutiveness of the previous set of valid parentheses. Alright, so then we make the result as 0 and then will encounter this, and result will be, I mean uh, this will be pushed into the stack, and when this comes the result will be incremented by 2. So now res is equal to 2, and when this comes into the stack, uh, we'll just push this, and when this comes we'll just pop this particular element, making the result to be incremented by 2, which is already 2. So we just have the rest, we just have the rest to be 4. Alright, so now finally we have the rest as 4, and we also have an answer variable which just compares the max, which just obtains the maximum. So we have the rest as 2, and we make the answer to be 2, and then when the rest is 4, we return the maximum of answer and rest, making the final answer to be 4. We just take the maximum of 2 comma 4. Alright, so this is an easy test case and this can be easily identifiable, but there is this below test case where we have to consider, I mean, where the breakpoints are in the form of open parentheses. Alright, so here the condition is the this has to be a closed parenthesis and the stack is empty, indicating that there is a set of valid parentheses previously, but now this has been broken by this. So this particular closed parenthesis doesn't have something like this here, so making that this is an invalid character. Yes, and so coming to the next test case, so here, so we have a set of valid parentheses for length 2, 4 and 6, and we can identify that this particular element or the character is the breakpoint only because this doesn't have something like this over here, or and this particular breakpoint, I mean this is a breakpoint because there is no closing parenthesis for that. So if we identify these two breakpoints, we can just make the result as 0 and do the same as the above test case. Alright, so we doesn't know that this belongs, I mean this breakpoint, I mean whether this character is a breakpoint until we pass until the end of the string, right? So there is this particular methodology that I have used to solve this problem, and what we do is just parse through the entire string and do the push and pop operations, except that we push the index along with the character. Alright, so when this is pushed, we push this this character along with index of 0, making that we can obtain easily the index of the breakpoint, right? So also for this, I mean, you may think for this particular character we are popping this breakpoint. No, just because this is in the top of the stack, and when this is encountered, we obviously pop this particular element from the stack. So we obviously have these breakpoints in the end of the operation present in the stack. So after we do, I mean, after we parse the entire string, we have these breakpoints remaining in the stack with the particular indexes, and so we eliminate these breakpoints. I mean, we make the rest as zero at these particular breakpoints by partitioning the entire string into different parts. So whenever there is a breakpoint, we obtain the breakpoints from the indexes present in the stack, and so we just divide the string into different parts. I mean, this is the first part of the string, and we have seen the previous approach or the naive approach, right? So we pass this particular string, this particular part substring into the naive approach or the naive function that we have already done, and then we leave this particular breakpoint as a invalid character, and then we also have this as the breakpoint, right? So until this breakpoint, we take the substring from here to this breakpoint and pass this substring into the naive function that we have already designed, and then also this. So each of this will return a particular answer. This will return 2, this will return 4, and this will return 6. And we easily maintain a variable that has the maximum of all of this and just return the answer. Yeah, this is a lot to know. I mean, there is a lot to know and understand here, but once you understand this becomes very easy and straightforward. I think I've explained the two crucial test cases that you should consider in solving this particular question. You can come up with any other solution. If you have any other optimal solution, just post it in the comment, guys. I'll always read the comments. I'm also posting the code in the description. I will be giving links. If you have liked this video, if you like my explanation, thank you so much, guys. Subscribe to my channel. I'll be uploading more content. Thank you.